Welcome to the Photon Frenzy activity demo. This experiment is designed to teach students about the quantum properties of light and demonstrate some of the consequences of light being quantized into photons. After this experiment, your students should understand that light is quantized into particles called photons, that the energy of a photon depends on its wavelength, which is determined by its color, and that photon energy can affect the way that light interacts with matter. In this experiment, students are given a sensor LED board, shown here, which turns on this indicator LED when you shine light on the sensor LED here. They will explore how different colors of light affect the sensor. They should find that blue light can still turn on the LED, while yellow light is incapable of doing so. To understand this phenomenon, you need quantum mechanics. When photons strike the sensor LED, electrons are knocked loose and amplified by a transistor circuit, which causes the sensor LED to turn on. However, there is an energy barrier inside the LED which incident photons must overcome in order to knock an electron loose. Blue photons have a short wavelength and a high enough energy to cause this, resulting in the LED turning on. Yellow photons, on the other hand, have a longer wavelength and lower energy, which is incapable of causing a current to flow. This experiment is inspired by the photoelectric effect. This was the observation that ultraviolet light could physically eject electrons off the surface of metals. The inability of lower wavelength light to eject electrons, no matter how high the intensity, perplexed scientists until one scientist proposed an explanation using the quantization of light into photons. That scientist was none other than Albert Einstein, who won a Nobel Prize for this groundbreaking work. So, when you share this with your students, you can proudly tell them that they're diving into some of Einstein's theories. Now that we have covered the background, we can go over the details of running the experiment. First, show the students the introductory video that we have produced for you. It will describe how the sensor board works and introduce them to the concept of quantization of light. Next, pass out all the materials to the students. Each group should receive one sensor board, one battery, one LED, 2 wires, 1 flashlight, 1 blue filter, and 1 yellow filter. Note that the filters you receive may differ in size from the ones that I have here. Next, have the students watch the assembly instructions, then assemble the boards themselves. I'm going to quickly assemble it here myself, but the assembly instructions include much more detailed steps on how the students can assemble it themselves. When they test their boards, they should not be using any filters on their flashlights. We want them to make a hypothesis about how the light color will affect the sensor board before they actually perform the experiment. Next, the students should try putting filters in front of their flashlights and observe how the light color changes, making sure to note these observations. We are looking for something like how the light color and brightness changes when we put the filter in front of it. For example, students may say the blue filter makes the light appear blue, but and decreases the brightness, while the yellow filter makes the light appear yellow, but does not appear to lower the brightness. From this, they're going to form a hypothesis about how the different lights will affect the sensor board. This part was made to be a little bit misleading and give them a surprising result. Many students will perceive the yellow light as brighter than the blue light, so they might expect that the blue light will no longer light up the sensor board, while the truth is the exact opposite. After forming these hypotheses, the students now get to test them. They should put the blue filter in front of the flashlight and shine it on the board and observe that the light still turns on. Well, if they take the yellow filter in front of the light and shine it in front, it no longer lights up. Students who are a bit more technical may try holding the light fixed and swapping out the blue and yellow filters to see how they compare, like so. You can see that the blue filter does not change the brightness of the light, whereas the yellow filter causes it to turn off completely. Some students may try holding the yellow light very close to the sensor LED, which can still cause it to light up because the yellow filters being used are not perfect. For example, when you hold it very close, it eventually will light up. As long as the students can discern that the yellow filter reduces the brightness of the sensor board, they can still learn the essential concepts, but I think it's important that you know why this may happen so you can explain it to them. Students will then attempt to explain their observations using the quantization of light into photons. The conclusion section is designed to get the students thinking about what happens if a lower energy photon strikes an electron by using an analogy of a ball in a valley. If the ball is kicked too softly, it will not escape the valley, just as a low energy photon will be unable to knock electron loose and cause current to flow and light up the LED. After the students have made an attempt at answering the conclusion, they should watch the final video we have prepared for them, which will explain how the photon energy actually affects the interaction with the sensor board. They should then update their answers after watching the video. After all, scientists are constantly refining their understanding of the world as they uncover new evidence. Thank you for your time, and we hope that you and your students have a blast with Photon Frenzy.